Okay, hello everyone. Welcome back. Today we're going to look at in this session, we'll be covering the homework question from the last session. This is Hoke's Spokes. John Hoke owns Hoke's Spokes, a bicycle shop. Most of John's bicycle sales are customer orders. However, he also stocks bicycles for walk-in customers. He stocks 3 types of bicycles: road racing, cross-country, and mountain bikes. A road racing cycles cost $1,200, cross-country bike costs $1,700, and a mountain bike costs $900. He sells road racing bikes for $1,800, cross-country bikes for $2,100, and mountain bikes for $1,200. He has $12,000 available this month to purchase bikes. Each bike must be assembled. A road bike takes 8 hours to assemble, a cross-country bike takes 12, and a mountain bike requires 16 hours. He estimates that he and his employees have 120 hours available to assemble bikes. He has enough space in his store to order 20 bikes this month. Based on past sales, John wants to stock at least as many mountain bikes as the other 2 combined because mountain bikes sell better. How many of each bike should John stock to maximize his profit? So first thing we have to do, as always, is translate this from natural language into mathematical equation format. Once again, we're going to move quickly through this because this should be getting to be easy at this point. We get 600x1 plus 400x2 plus 300x3. The reason is we're trying to determine profit. Profit is revenue minus costs, and our costs are given here. So for each of the 3 bicycles, I took the revenue from each and I subtracted the cost of each bicycle. That gives us 600 plus x1 plus 400x2 plus 300x3. Our first constraint, 1200x1 plus 1700x2 plus 900x3, is the cost of each bicycle, and it has to be less than the $12,000 that he has available this month to purchase bikes. Our second constraint, 8x1 plus 12x2 plus 16x3, is less than or equal to 120, and that is assembly time, the amount of hours it takes to assemble each bike, plus the total amount of hours he has for bike assembly. The third one is x1 plus x2 plus x3 is less than or equal to 20, and that's based on the fact that John can only keep 20 bikes in his shop. So the total of 1, 2, and 3 has to be less than or equal to 20. Finally, the final one, x3 is greater than or equal to x1 plus x2. And this is similar to what we saw last class. We convert to x3 minus x1 minus x2 is greater than or equal to 0. This is our final computer-appropriate problem formulation. From here, we only have to move on to our computer program. So let's go into QM first. We're going to Module, Linear Programming, open a new file. We have 3 variables to work with, and if we check here, 4 constraints. And we're trying to maximize our profit. So we hit OK, and we lengthen our columns. This is unnecessary, but we do it anyways. The first one is road bike, second cross country, and the third, just very quickly forgot, oh no. The third is mountain bike. We're taking our 600, 400, 300, which is our profit per bike minus our cost per bike. Our first constraint is purchase money available. And here we have to check our numbers. 12, 17, 9. And we have $12,000 available. Our second constraint is assembly time. 8, 12, 16, 120. So 8, 12, 16, 120. Our third constraint is storage space. 1, 1, 1, and we have 20 bikes available. And the last one is sales ratio. And we made the mistake last time. I won't do it again. -1, -1, and this one is +1, and it's greater than or equal to 0. So we've entered all of the information appropriately. All we have to do here is click solve. And we see that we should stock 5 road bikes and 5 mountain bikes, which will give us a total of 10 bikes, less than 20. Our assembly time is less than 120, and we're spending less than $12,000. That will give us a maximum profit of $4,500. And that's the Hokes spokes example. And we can close this program. Then we open a new spreadsheet. And we do Hokes. You'll notice how quickly we are going now, because this should be very easy at this point. Products, road, cross, mountain. I guess we'll make them a little bigger. Doesn't hurt us. Profit, 600. 400, 300. Our constraints. The first one is purchases. The second one is assembly. The third is storage. And the fourth is sales ratio. We come over here, and this is where we enter our usage and available. Usage we'll leave blank for now, so this is less than or equal to, less than or equal to, less than or equal to, greater than or equal to. 0, 12,000. 120 hours, 20 spaces available. For purchases, over here, we can check our, if we're unsure, 12, 17, 9. Assembly is 8, 12, 16. Storage is 1, 1, 1. Sales ratio is -1, -1, 1. And we see over here, all of this is completed so far. We go to products, road, cross, mountain. And we're trying to maximize our total profit. Profit we can do right now, which is this times the number of road bikes we sell plus this amount of money times the number of cross-country bikes we sell plus this amount of money times the amount of mountain bikes we sell. Over here, which is here, times the amount of road bikes we sell plus this number times the amount of cross-country bikes we sell plus 900 times the amount of mountain bikes that we sell. We repeat one more again. one more time. And finally, we hit enter and we've completed everything appropriately. The last thing, the only thing remaining for us now is to come up to our data solution, go over to Solver, and enter the appropriate cells here. The first one, we're trying to maximize profit in B18. The variable cells will be B14, 15, and 16. We're adding for each of these less than or equal to. The only one we have to be careful with is this last one. Greater than or equal to 0. Oh, we're going to close that for 1 second because there was a small mistake made here. Equal this times this plus times this plus this times this. There we go. So we click on the solver. I just made a mistake with the formula a minute ago, and we change this to simplex LP. We hit solve. Oh, something went wrong. 1 second. Let me pause this and check. Okay, everyone. I'm sorry. I made one small mistake over here, right in this this example right here, and that led us to a solution that was different. So what we have now is 5 road and 5 mountain as before, with a profit of 4,500. I'll save this. And what I can close this program. What you are going to do now, I don't know why that shut down, but what you're going to do now is complete homework problem number 2. This is your homework problem. This is 15% of your final grade. This is the reason I'm giving you all of this time now, is because this is 15% of your final grade. I will upload right now all the instructions that you need to complete this homework problem, but you must solve it, and I will give you instructions in your next session on how to submit it. It has to be solved in Microsoft Windows, Excel, and QM for Windows. If you do not have access to those programs, you have to go to the school to access them or find some way to access both of these programs. This is the problem. I will address you again at the 40-minute mark. I will also upload this to our Kakao group chat. Thank you for listening. Good luck. If you have questions about this, as always, please contact me, but please read the messages carefully before you contact me. Again, this is homework problem number 2. It is an individualized homework assignment. It is 15% of your final grade. All of the other key information I will send to you on Kakao. There is no attendance quiz today because homework problem number 2 will function as your attendance. I will address you again at the 40-minute mark. All right, everyone. Again, hopefully you're having no problems with this. If you want to contact me about the instructions, that's fine. However, I will not be helping you with this problem because it is a homework problem. It is part of your final grade, 15%. So good luck, and I hope everything works out well. Again, if you do have problems, please check the message I send on Kakao, and you can message me on Kakao for those problems. Thanks again for watching. Good luck with your homework assignment.